aliens. At least that's what I think the topic of this video is about. I don't actually know. What up guys, Otterpop here, and today I am watching another Let Me Know video, but this one is going to be a little bit different. In the past, I have done analyses on Let Me Know videos that focus on, mysteries and forensics and, that kind of stuff. But I was like, okay, somebody give me some forensic, science, mystery type material. And apparently this one was a recommendation. It's called The Great Silence. Now, I don't exactly know what it's about, but the thumbnail is interesting because it presents like a satellite dish, like what you commonly associate with people trying to communicate with aliens or, the better term, honestly, extraterrestrial life. Besides, some of the comments seem to mention stuff about, aliens and extraterrestrial life, so I'm going to assume that that's what this is about. So, to preface, do I believe that there is extraterrestrial life somewhere out there? Personally, I kind of do. Because if you think about it, there are billions upon billions of stars, so many of which we can't even see in the night sky. They're just that far away, or they just, what's the word I'm looking for? They just don't illuminate that much. Heck, there are even some stars that are very close to us that we simply can't see because they're just too small. They're just little baby giants. I mean, granted, our sun is pretty small. I'm pretty sure it's just it's not even a red giant. I think it's just a yellow giant, I think. Wait. A lot of articles seem to classify it as like a middle-aged yellow dwarf, so not even a giant, just a dwarf star, which I feel like I didn't even realize that. I didn't realize that our own sun was a dwarf star, but but in any case, it seems a little bit silly to assume that of the billions of stars out there, the hundreds of millions, maybe even more of galaxies that exist out there, that our planet is the only one with life? Come on. There is no way that our planet is the only one with life out there. Complex life? There could very well be other planets with complex life on them somewhere out there. Maybe not. I personally think that there is, but we just haven't come across them yet. Certainly unlikely to be in the Milky Way galaxy, although you never know. The Milky Way galaxy is certainly not as big as some other galaxies, but it's still pretty sizable. And obviously, we're still limited on the technology we have in terms of spacefaring and space exploration. We don't necessarily know everything that's out there. And heck, there are even reports of some planets that could potentially contain, water. Our civilization, technologically, is relatively advanced. I think it's possible that there could be even more advanced technological civilizations out there. It is most definitely possible. I feel it's silly to assume that we're the most technologically advanced, because I feel like there's so much technology that we don't have that theoretically could be feasible given the laws of physics and chemistry. Anyways, sorry about that. I've been ranting on long enough. Let's go ahead and watch Let Me Know's video on the Great Silence, and we'll see exactly what he has to talk about this. This video was also a little bit older than some of his other videos. I want to say it's around the same age, if not older, than The Lost Colony of Roanoke, which I personally love that video. That was actually a really good video. I was able to provide a lot of commentary on it, and brought me back to a time where I was like, yeah, I remember learning about this. Just a bunch of fascinating stuff. This stuff is more bits and pieces. I have information on this general topic, and obviously speculation of sorts, but I don't have a lot of information, and I don't know exactly what perspective he's gonna take with this particular video.
Just let me know.
Let me know. Yeah, you let me know what you're talking about.
In 1967, a postgraduate student at Cambridge University by the name of Jocelyn Burnell was surveying the sky with a newly constructed radio telescope. After a few weeks, she discovered something odd. The telescope had picked up a radio signal that seemed to be pulsating. The pulses had an interval of exactly 1.33 seconds and were initially thought to be nothing more than man-made interference. However, it soon became clear the signal did in fact emanate from deep space, and the unwavering precision of the pulses was unlike anything seen before. As such, many questioned whether it was a naturally occurring phenomenon or a transmission from another civilization. The radio source was even named LGM-1, an acronym for Little Green Men, and Burnell herself could not
Ow.
help but wonder if she'd actually discovered the first sign of life beyond the Earth.
I find it interesting that whenever people think of aliens or extraterrestrial life, which I'm gonna use the term extraterrestrial life. I prefer that term, frankly, not alien. I don't know. Alien feels, what's the word I'm looking for? It feels inappropriate for some reason. I'm not sure if that's the best way to describe it, but that's kind of the general feeling that I feel when I use the term alien. So I'm just going to use extraterrestrial life. But why is it when the first thing we think of when we think of extraterrestrial life is little green men? Why green? Why was that the color that was picked for for the first for the first image that pops into our heads as a result? Like granted, all we think of extraterrestrial life and we stereotyped it as, yes, little green men. Why is that? Why did it start as green? Why was green the color that was picked? It's not even that unusual of a color or anything like that. I don't know, maybe like skin tone. I mean, technically yes, it's probably about the furthest, green is about the furthest color from normal skin tones. Because I mean, if you think about it, a lot of us are very like pale in color. I mean, certain, and I'm just talking about from a Caucasian perspective. Obviously, there's a whole range of skin tones, mostly from like the pale ivory and the practically translucent. There are some people that have some crazy pale skin to very dark, you know, browns, almost blacks, but not quite blacks, but very dark browns. So it's a huge spectrum, but it's actually a very small spectrum given the entire color spectrum, if that makes sense. So I don't know. Maybe green's just the most unusual color you think of when you think of skin. Because there are some certain skin conditions, and not even skin conditions, certain medical conditions too, where your skin color can be very odd. Like if you have if you have an overproduction of certain substances in your body, you can almost have like reddish or orangish skin, which is most definitely unusual. I mean, heck, even like pure black and pure white skin tones are possible in the human population, but they're just exceedingly rare. So even something that's, you know, pure of one color or the other, in as simple of colors as black and white, is still exceptionally rare. So I don't know. It's still kind of interesting that green was the color chosen to stereotype the appearance of extraterrestrial life, like little naked green men for whatever frickin' reason. And when he was starting to talk about this LGM1, I honestly thought he was gonna talk about a different event. What is it called? I might actually have to look this up. Okay, for some reason I'm having difficulty trying to find the exact event that I'm trying to look for. It was somewhere around the mid 1900s, like somewhere between like the 1950s and the 1970s. Not this incident, but where somebody noticed like these strange readings as they were going through. I wish I could remember more about it. If I heard the name of it or if I saw a general synopsis of it, I'd be like, yeah, that's what I'm talking about. I wish I could. Where, like, the wow signal, oh my gosh. Oh, thank God I remembered it. I had to look it up real quick. It was 1977 was when the wow signal was first noticed. It was this little jumble of letters and numbers, and it was literally circled. It was like the sheet was printed out. The strange numbers and letters were circled, and wow with an exclamation mark was written right next to it. That was one of the first like real possible indications, like not real indications, but real possible indications of, you know, maybe extraterrestrial life. I think it was later discovered that it could very well have been like from a comet of some sort. So that theory of extraterrestrial life was disproven. But it really started to spark up the debate. Could there be extraterrestrial life out there? And have I heard anything about, you know, if there's possible alien life on another planet or just out there in deep space somewhere? No, and possibly we won't unless, you know, we actually get an obvious signs that, you know, extraterrestrials are or have come to Earth or something like that. Obviously, there's so many conspiracy theories. Do I necessarily believe them? Not particularly. Not to say that it's impossible that extraterrestrials have not visited our planet in secret before, maybe even on numerous occasions. Technically speaking, it could be possible, but I also find it extremely unlikely, personally. Any conspiracy theorists out there, please just don't hound me, okay? I'm a very scientific individual. I need solid evidence. I need hardcore proof that extraterrestrials have visited us. And so far, I haven't seen any. So, again, is it potentially possible? Because I don't like to use the terms always and never. Because they're words. They're definitive markers. Like they're 100% definitive. And I don't like to use that. Especially as a forensic scientist, being the way that I studied, we were taught not to use the terms always and never. Does it come up in my vernacular every now and then? Sometimes when I talk about videos? Yes, it might. But I try not to use them to the best of my ability because they're so definitive, when in reality, the majority of things that we know, technically speaking, aren't definitive. There are certainly some constants that we can, that we can measure. Like, we can say that, shit, I'm trying to think of an example. Failed. In any case, in forensics, we were taught to use the terms less likely, potentially, very likely, like likelihood. Not the always and the never part. I mean, theoretically, I could actually in this instance say we were never taught to purposefully use the terms always and never. At least from what I remember. And it was a small group of forensic science professors, but I never got taught that. I was taught not to use the always and the never because they're too definitive. There's a specific word I'm looking for, but they're too set in stone terms that you should not be using. So circling all the way back to what I was saying is it technically possible that extraterrestrial life has visited us in the past more than once, or just, at all? Technically, yes. But I personally find it very unlikely. Got it? Get it? Got it? Good. That's a cool effect, by the way. Having the blips just phase in and on stacked on top
As
of
you
each
might
other like that.
expect, it didn't take long for natural explanations to emerge, and we now know these pulsating signals to be produced by rapidly rotating neutron stars, known as pulsars, that
Yep.
emit beams of radiation akin to the beams of light emitted by a lighthouse.
Space is
If nothing
crazy.
else, it made for a neat album cover. Ever since, an international effort known as the Search for Extraterrestrial Intelligence has actively been listening for artificial transmissions, but so far we appear
That's
to be
right,
the
I've heard
only
of
ones
SETI.
broadcasting into the void.
I forgot
Humanity has
about
been
them.
making radio signals into space for the better part of a century, so any eavesdropping aliens within about 100 light years could potentially be alerted to our presence. Beyond this invisible radio bubble enveloping some 15,000 stars, the Earth is just another silent speck. Not only that, but as technology improves, this radio leakage is dramatically reduced. Before long, Earth may return to a state of radio silence. If most civilizations improve and eventually outgrow radio technology at a similar pace, the radio signature of any one civilization may only be detectable for a very brief period of time. Furthermore, this radio
Fair.
leakage is extremely faint and only grows more and more diffused as it expands into the galaxy.
Oh yeah.
Some of the most powerful signals to leak into space are military radar emissions, and stand a much better chance of detection across interstellar distances than the average television broadcast.
Yeah, I mean, it is crazy if you think about it. The technological advancements that have, improved over even just the last century. Like radios, so different compared to what they were a century ago. Televisions didn't even exist as well, actually. No, I think they did. Moving pictures were a thing a century ago. I just can't remember if televisions. No, I didn't think televisions were actually a thing until the 50s. 40s? Wait. I know that. Wait. I'm really messing up my timelines right now. Okay, so so I keep seeing reference to television and broadcasting, which were kind of right around the same time, which seemed based on there are so many different articles and stuff, and some of them I don't necessarily know the legitimacy of them, but a lot of them do seem to mention sometime around the 1920s. So technically, television did exist, but not nearly like what it is now, especially given the internet. The internet. No, no, no. The internet did not exist 100 years ago. That much I know. The internet didn't crop up until the 90s. Think after I was born. I'm older than the internet. Not by much. Damn, alright. Or at the very least, I'm just a little bit younger than the internet. In any case, I'm right around the same age as the internet. Why is that mind-blowing? But in any case, our capability of transmitting and receiving data, I kind of combined the two for a moment. Our capability of transmitting and receiving data is so vastly different than it was even like 50 years ago. And like Lemino said, there are so many operations that are capable of sending out signals, but that doesn't necessarily mean that they're going anywhere fast. Sure, in some cases they can practically be instantaneous communications, but in other cases it may take a few minutes, a few hours, maybe even a few days, depending on the type of communication received and whatnot. But we're also, in a sense, in an enclosed space, which is, our planet. And you may be thinking, yeah, but there's really nothing out in space. Well, if you think about it, it's not just expanding on a 2D space. There's not just the X and the Y. X and Y. I don't know why I did it the other way. But there's also a Z now, too. There's a three-dimensional space that these transmissions could be expanding. And just because it's empty space doesn't necessarily mean that it can transmit all that distance. I mean, you really think that something that crystal clear is going to transmit even to the edge of the solar system? Like, in some cases, maybe. But it's still going to take a while because our technology, in a sense, is still underdeveloped. Heck, even look at something like Bluetooth. Bluetooth is sort of like a wireless connection of sorts, but there's a limited distance where it can work. So, and I've actually done some tests with this for some of my company's products. I actually had to do a test for this sometime last year, sometime in the fall, I believe. And the further away you are from the instrument, the less effective the Bluetooth is until it flat out just disconnects. We're talking like like comparing distances between 10 and like 60 feet. Like 60 feet away, the Bluetooth kind of bugs out, and in a lot of cases it'll just flat out disconnect. But it's very strong within about like a 5 to 10 foot radius. But the further away you start getting, the slower the communication, because that's just how transmission works. It's gonna fail. It's gonna get buggy. It's frankly gonna dissipate. Even regarding, expansion into actual empty space. And if you think about it too, maybe say it hits a planet. It's going to diffuse so much once it hits a planet, and it may even disappear going in that direction as well. I mean, it may still kind of be there, but not necessarily all that well. Transmission of radio waves I didn't learn too much about that in my physics class. I think we either spent maybe like a few lectures, maybe a week on it at best, but we did not study that stuff to any particular effect. Because that's not what you really focus on in basic physics. Maybe more advanced physics, possibly. Definitely definitely like, in engineering, especially electrical engineering, because stuff like that is kind of what a few of my coworkers have to deal with, being electrical engineers and all. Heck, even the software and firmware developers kind of have to deal with stuff like that from time to time as well. So there are certain aspects that can look a little bit more into radios and transmissions, but for basic people, not really. We don't need to know the specifics of it. We just need to know that it works, for the most part. And the further out you extend a transmission, the more it's going to diffuse, and the groggier it's going to get, until it just flat out disappears. And who knows how long that those transmissions are going to last. Obviously, with our advancements in technology, they're going to last longer over time. But they're still not infinite.
The Square Kilometre Array, a vast interferometer to be constructed in South Africa and Australia, could be sensitive enough to detect the faint radio signature of an Earth-like civilization out to a distance of several hundred light years. To detect more
Damn.
distant signals would require more deliberate attempts at communication. For instance, an advanced civilization may construct powerful beacons specifically to increase their radio luminosity. These beacons would be rather expensive to maintain as they would consume vast amounts of
Oh
energy
yeah,
for extended
lots
periods
of
of time.
electricity and
A
energy.
less expensive alternative would be a focused beam of radiation as opposed to an omnidirectional broadcast.
True.
In 1974, the Arecibo Observatory in Puerto Rico famously beamed an interstellar message towards a globular cluster some 25,000 light-years distant. The message took less than 3 minutes to transmit, so any prospecting aliens in the path of that signal would have less than 3 minutes to detect it, and they will never get a second chance. We may have been on the receiving end of such an interstellar message when in 1977, a momentary burst of energy swept across the planet.
Wow, the
Repeated
wow
attempts at
signal.
redetection notwithstanding, the famous WOW signal
Yep.
was never detected again,
What did I
and its
say?
origin has never been conclusively ascertained. On the slim chance that it was of artificial origin, a reply was beamed in a general direction whence it came in 2012.
Okay, so the realization that the wow signal was probably from a comet must have been discovered after Let Me Know posted this video, which again, I'm pretty sure that this video is from 6 years ago. So that discovery is from a more recent time frame. Okay. Yeah, I mean, that's the thing too, is that, you know, if you want to send a continuous straight beam of a transmission with, you know, whatever message, audio, photo, visual, stuff like that. If you want to send that, that's going to transmit for much longer. It has a much more it has more efficacy, but it's also extremely limited because you're talking about shooting in one particular direction, and there's no guarantee that it's going to reach anywhere. It has a much greater range, but at the disadvantage of, you know, being very limited in where it can actually go, since everything else is moving around too. It's not just us. Every other star and planet out there is moving. Every single one of them is orbiting, is rotating, is shifting. I mean, who knows? But again, the problem with omnidirectional is that it takes so much, it consumes so much more energy. You know, whether it's electricity or something else, it takes so much more energy to be able to do that. And even then, it has a much shorter range because you're trying to shoot it in all directions out at the same time. It's gonna diffuse a lot easier.
In a galaxy as old and vast as the Milky Way, the probability of
It's
two
not even the
civilizations
oldest.
stumbling upon one another by briefly screaming in random directions is not great. To increase our chances, we need to limit our selection of targets by searching for other technological and biological signatures. In 1995, the first extrasolar planet orbiting a sun-like star was discovered.
That's right,
We now
Pegasus
know
B.
that the vast majority of the hundreds of billions of stars in the Milky Way galaxy are home to at least one planet. We also know that
Oh yeah.
billions of those planets are of similar size to the Earth and orbit within the habitable zone of a star similar to the Sun. This
Habitable
means that
zone.
liquid water could exist on the surface, which is an essential ingredient for life as we know it. Furthermore, billions of extrasolar moons may also be capable of supporting life. With this knowledge in mind, in 2017 a message was beamed towards one of the least distant and most Earth-like exoplanets discovered to date. The message comprised a number of musical compositions and basic information about humankind, and should the planet be inhabited, we
Luton
could expect a
B.
reply as early as
That's right.
2024. Here's a quick preview of that future.
So funny enough, I've actually done a little bit of research on a lot of at least the nearby exoplanets within the Milky Way specifically. I haven't done some research outside the Milky Way. I haven't even finished it in the Milky Way, but I haven't finished the research. Anyways, I tend to focus on writing fantasy novels. But I do also have a space opera idea for whatever freaking reason, and I thought it would be a good idea to do as much research as I could on, you know, other stars, solar systems, exoplanets, and stuff like that. These two planets, Luiten and Pegasus B, were two of them that I actually have researched a little bit. Not too much, but enough to make educated guesses. But yes, these two are some of the most well-known exoplanets that are in the habitable zone, because habitable zones are different for different stars. Bigger stars, the habitable zones are going to be further away than, say, with our little yellow dwarf star. Because the bigger the star, the hotter it emits. But humanity has discovered multiple exoplanets, even within the Milky Way alone, that are in that habitable zone, that either likely have, signs of life, or at the very least water on them, or could potentially. And what I did is I did a bunch of research on a number of different planets so far, and decided for myself, okay, this planet I would like to have life. This one, not quite. This one's not quite habitable. And, there could even be a possibility too that some of these planets could have life, but they might not be technologically advanced enough to be able to receive those messages or transmit anything back. I think it makes the most sense personally if it's one of those situations where you can't do one without the other. You can't be able to send a signal without receiving it first, and you can't be able to receive a signal without also having the capability to send it out, if that makes sense. But yeah, there's only so much that we can do, especially because our solar system is kind of on the fringes of the Milky Way. It's kind of right around the edge of it. So there's still we're right here, and there's an entire galaxy way up here, and we're still discovering, you know, potential exoplanets. We haven't discovered them all yet in the entire galaxy, not even close. But we're still discovering about these potentially habitable planets that could harbor life on them. I'm actually quite a big fan of the show The Expanse. I'm not sure if any of you have seen it. My partner introduced it to me. I'm not big on like sci-fi and space opera type stuff, but I knew it meant a lot to him, so I decided to get into it as well. It's interesting because it pretty much only takes place within the limits of the solar system, and it's crazy how advanced technology is in The Expanse, and yet it's still only limited to the solar system. There's still so much that is not known about extraterrestrial life in that series, and there is kind of extraterrestrial life involved in that show. Not as much as you'd think, though, because The Expanse is mostly focused on humanity and human characters for a good reason. It actually explores different human elements very well, I dare say, especially in the early seasons. But even with all that advanced technology, there's still little to nothing known about existing or potentially extraterrestrial life, despite the fact that it's set so far forward in the future, like by a few hundred years, I want to say. But just imagine, like, if we were, say, the most technologically advanced society in the Milky Way at the very least, there's a good chance that any other habitable planets out there won't even be able to receive whatever signals that we are sending. And if that's the case, well, what can you do? Apparently some of these transmissions can reach very far, faster than I anticipated. I'm also not really sure how they can tell that, but I suppose as well, if you've studied a planet long enough, exoplanet or not, or if you've studied a star or a planet long enough, and you're able to map out the orbit and rotation of your own planet and the orbit and rotation of the other planet or star or heavenly object, then theoretically you do very well have the possibility of sending out a signal, like a direct signal, a direct beam of transmitted signal right to the destination that you want it to be at. There are plenty of scientists that know how to do that stuff. It's crazy math. I don't understand how they can do it, but I'm not questioning it. I trust them. Because clearly they've been studying this crap. I have not. This is not my wheelhouse. I am interested in some aspects of this, but this is never anything I studied. I'm not questioning it. I trust them. Because clearly they've been studying this crap. I have not. To clarify, this is something I've never professionally studied. Have I personally studied it? Kinda, sorta, not really. Have I professionally studied it? No, never.
Here's a quick preview of that future. However,
Goes to my
habitability
nearby
is no
planet.
guarantee of habitation. To determine whether a potentially life-supporting planet is currently supporting life would require a more careful examination. For instance, by analyzing the starlight passing through the atmosphere of an exoplanet, it is possible to deduce its chemical composition.
That
The
is true.
spectrum of an oxygen-rich atmosphere will differ from that of, say, a hydrogen-rich atmosphere. Given that photosynthetic
Spectrum
plants and
photography.
organisms are responsible for the large quantities of oxygen on Earth, an exoplanetary atmosphere with a similar concentration of oxygen could be taken as a sign of life. This is known as a biosignature, but it's far from definitive, as oxygen could also be the result of various abiogenic processes. As such, astrobiologists are more interested in certain chemical combinations, as it would be far less likely for, say, methane and carbon dioxide to coexist in the absence of life. Speaking of carbon dioxide, some chemicals could be indicative of industrial pollution, and thus artificially induced climate change could serve as the universal sign of unintelligent life.
Well, something else to consider as well is that, technically speaking, there's no determinant factor on. I mean, okay, technically, okay. Backtrack. I do think that water is one of, if not the core element that needs to exist in order for there to potentially be life. I think that's almost a universal constant. It may not necessarily be, but I think that it is, and it makes sense for that to be the case. However, I don't necessarily think we can say for certain that oxygen is required for there to be life. Pretty much most of the living organisms on this planet depend on oxygen in some form, but that doesn't necessarily mean that's true for all life. If you look, there are plenty of anaerobic bacteria and microorganisms that don't need oxygen but need other substances in order to survive. Who's to say that life didn't potentially develop to also not require oxygen to survive, but other substances? Maybe not necessarily carbon dioxide or methane, but even something maybe, say, a little bit more nitrogen rich, because nitrogen is a very important and prominent substance in multiple planets all over the place. I'm pretty sure it's a prominent element of Uranus, Neptune, or both. I can't exactly remember. It's a prominent part of one or both of their atmospheres, though. But I mean, is it necessarily a 100% true fact that oxygen is required to support life? I don't necessarily think so. I think it's the most stable and one of the most likely indications that life could be, could exist, could thrive, could develop. But I don't necessarily think that that could be the only requirement. I mean, I could be entirely wrong, but looking from a chemistry standpoint, from an evolution standpoint, I don't think oxygen is always a requirement. Water? Very likely could be. Oxygen? Possibly not.
And thus artificially induced climate change could serve as the universal sign of unintelligent life. In addition to
Does that mean we're
biosignatures,
unintelligent
we may
life?
be able to detect signs of technology. For instance, an exoplanet surrounded by a dense orbital belt of artificial satellites or space debris could be detected during transit of its parent star. This would be an example of a technosignature. A more extreme example would be a megastructure.
Megastructure around an
Initial
entire
speculation
planet?
surrounding the discovery of pulsars has become somewhat of a recurring theme. Whenever an astronomical discovery initially defies explanation, vigorous speculation about aliens takes center stage.
Naturally.
In more recent years, this discussion has been dominated by a peculiar star some 1500 light-years distant. The star exhibits erratic light fluctuations and occasionally dim by as much as 22%, and so one hypothesis
Damn.
is that an alien megastructure is blocking the light from the star. While evidence of astroengineering is still within the realm of possibility, the dimming is now thought to be caused by nothing more than dust. The existence of circumstellar
entirely possible.
megastructures was popularized by theoretical physicist Freeman Dyson back in 1960 as a potential means for advanced civilizations to harness the energy of their parent star, commonly known as the Dyson sphere or Dyson swarm. According to the Kardashev scale, a method of measuring a civilization's energy
Sphere less
consumption
likely
proposed by
swarm?
astrophysicist Nikolai
Plausible?
Kardashev in 1964, a Dyson sphere would be indicative of a Type 2 civilization. A Type 1 civilization could harness the energy of its home planet. A Type 2 civilization could harness the energy of its parent star. A Type 3 civilization could harness the total energy output of an entire galaxy. Extensive
Jeez.
surveys of billions of stars
That's
notwithstanding,
quite a jump.
there is no reliable evidence of a Type 2 nor Type 3 civilization in the Milky Way galaxy. So far. What about extragalactic life? After surveying 100,000 nearby galaxies for signs of a Type 3 super civilization, astronomers found no signs of a galactic empire.
Yeah, but how are they looking? How are they, like, looking and scanning for that kind of stuff? And Type 1, would we classify as a Type 1 technically? Humanity?
The great silence of the universe can be a bit unnerving. Humanity is now on the verge of detecting biosignatures on extrasolar planets, but Earth has been radiating detectable biosignatures for billions of years. Yet, as far as we can tell, it's failed to attract the attention of any alien astronomers. The apparent contradiction between the expectation and lack of evidence for extraterrestrial life is known as the Fermi paradox.
I love the Fermi paradox!
The age of the universe, why does it appear to be so lifeless? It is possible to concoct a myriad of hypothetical solutions.
Yeah, there's so many hypotheses for stuff like this.
Common, while intelligent life is exceedingly rare. After all, it took some 4 billion years of evolution and a number of mass extinctions before humans emerged on Earth. Proponents of
and
the rare
thrived in unimaginable ways.
That complex life on Earth is the result of an improbable chain of events, unlikely to occur more than once. Perhaps there exists a barrier, either improbable or impossible for life to overcome. If the barrier is behind us, we
almost encountered it multiple times.
Crossed it. Potential candidates include the emergence of multicellular organisms and the invention of nuclear weapons. If the barrier is still to come, we may soon join the cosmological graveyard of fallen civilizations.
Which I think is entirely possible with humanity.
And the invention of nuclear weapons. Perhaps we severely underestimate how truly alien aliens can be. All life on Earth is carbon-based and rely on water, but life could hypothetically be silicon-based and thrive in oceans of liquid ammonia. Just as we
that's what I was talking about.
Know it, aliens may be doing the same.
That's exactly what I was talking about earlier, though, is that we are carbon-based life forms, and we thrive on oxygen in order to survive. At our most basic level, oxygen and water in particular. But that doesn't necessarily mean that that's the same case for any other multicellular life anywhere in the universe, whether intelligent, not intelligent, or even hyper-intelligent. Like he said, it could be silicone-based, it could be, and they could have an ammonia or nitrogen-rich atmosphere or something like that. That is entirely possible, because elements can work in a variety of different ways, and how life develops can also work in a variety of different ways. This is how complex that life truly is. And at its base, how complex chemistry is too. I took 2.5 years of chemistry in college. And granted, I didn't necessarily retain all of it, but I also took a year of biology and a semester of microbiology. I know firsthand from my studies how incredibly complex life is. Not just from a societal standpoint, but from a base standpoint of a single cellular organism, multicellular life, chemistry balances. Life is so complicated. Our bodies are so freaking complicated. Just look at the number of genetic conditions, mutations, diversity that we can have in the human population alone. We're talking about billions of people, each with their own unique genetic signature. But we're all still humans. It is insane how diverse it is. And not only that, but every human and every hominid that has ever existed have all had their unique genetic signatures. We're talking billions, maybe even trillions of hominids over the course of just a few million years. And every single one of them was genetically different, even though we are all the same hominid. Largely, obviously there was a little bit of evolution here and there, but at least for the last few 100,000 years, or maybe even just the few last couple of, 10,000 or so years, we're all basically the same. Our genetic coding is just ever so slightly different. Different eye colors, different hair colors, skin tones, different, even our voices can all be different and unique in their own way. That's just the biological stuff. There's another layer to it as well, where we all speak different languages, have different beliefs, have different mindsets, different patterns of speaking, of walking, of thinking. Every single one of us is unique and different in our own right. Why can the same not apply to extraterrestrial life? Not every extraterrestrial organism is going to be a carbon-based life form that thrives on oxygen and water. There are gonna be differences. Heck, there may be some that are similar enough to us that can communicate with us very effectively, or could, go from planet to planet and not have an issue. There are some where our atmosphere could be toxic to maybe an extraterrestrial organism. We don't know. There are so many possibilities. And frankly, what Let Me Know was talking about as well regarding, based on the Fermi paradox, which I'm hoping that Let Me Know talks about. If he doesn't, I will, because I know a little bit about the Fermi paradox, and I love the Fermi paradox, man. That's one of my favorite theories and hypotheses. Wait, is it a hypothesis or a theory? It's one of the two. Is one of my favorite astronomical concepts regarding extraterrestrial life, because it just makes sense. It perfectly makes sense. But this planet has, through its 4.5 billion years of existence, endured so many different massive climate changes, 5 huge extinction events, and we could very well be another one. Humanity could be the cause of another one, in large part because of, reliance on fossil fuels and climate change. I do personally believe in climate change. I think it is a very real factor. Just look at the change of images from, say, the Arctic Circle in Antarctica, and even from forested areas in, say, like India and Brazil. Compare satellite images from 30 years ago, even 50 years ago, if any do exist, to today. And it's so vastly different. And I know you may think, evolution, planets are constantly changing. The planet doesn't typically change this much this fast. Humanity does have an impact on it. And unfortunately, we tend to have a very negative impact on it. We need to find ways to have less of a negative impact. And I know that's much easier said than done, but unfortunately, governments do help with that. I mean, just look at the EU. They have so many rules and regulations in regards to, climate change, and like the Paris Agreement, which unfortunately the US backed out of because Trump is an idiot. But stuff like that can be extremely beneficial, especially if we try to have more of a reliance on renewable resources and trying to, recycle more, reduce global warming and climate change potential situations. But at least on a widespread scale, it can most definitely start with legislation. If there's legislation, there's a much better chance that it'll have a more positive impact, or at the very least, a less negative impact. Because it's super hard to do it on an individual scale. And even if you do it on an individual scale, it might not have much effect. But if you do it on a much bigger scale, like, say, counties, states, even countries, even international divisions, it makes so much more difference. That's why legislations like that are very important for any government, any country really. So I personally believe that humanity could very well be the reason for either another mass extinction event or just a massive event like a some kind of catastrophe of some sort, extinction or not. I do think humanity will be responsible for a catastrophe that befalls this planet.
Just as we search for life as we know it, aliens may be doing the same. Perhaps an advanced civilization did in fact pay us a visit in the distant past, unless some sort of evidence of that visitation survived for millions or billions of years.
Dinosaurs actually
We'd
came from
never
another
know.
planet.
Even a visitation in the recent past could have been misconstrued as gods descending from the heavens. Well, I mean, that would have been a fairly accurate interpretation. Perhaps all civilizations inevitably
True.
develop technology that
Maybe God is actually an
transcend
extraterrestrial.
physical reality. For instance, reality could be rendered obsolete by hyper-realistic simulations. By transferring one's consciousness into these virtual wonderlands,
Oh,
one could
jeez.
achieve digital
I
immortality.
have nervous thoughts about this kind of
happenstance
stuff.
offerings of nature would struggle to compete with the promise of utopia.
Okay, I'm gonna slightly switch topics here because that is an aspect of technology that I do worry about, namely in the sphere of generative AI. So, for people who don't know, just a general summation. Technically speaking, generative AI is a facet of artificial intelligence as a whole, but artificial intelligence for the longest time, since at least like mid 1900s, I want to say, was used as like, for like analysis more than anything else. I mean, heck, lots of companies use AI in some form. I mean, a lot of the, like NPC programs in some games, especially in relation to, characters that follow yours, like say, Atreus from God of War or Ellie in The Last of Us. They are often referred to as, that character's AI, because, it does have to be developed in a very specific way. But typically with those AI, there's an analysis and a logical reason for them to follow. There are rules and regulations and limitations, and there are specific codings that have to be set in order to make that stuff work. Generative AI is a very different camp, still in the AI sphere, but it has a very different objective to traditional artificial intelligence. Generative AI basically takes existing data sets and creates something new from those existing data sets. Instead of being driven by certain algorithms and, rules and regulations, it's being driven by data of sorts, but not necessarily in the way that's used for lack of a better term, useful purposes. But yeah, unfortunately, generative AI is a little bit more contentious because it has undergone significant development, especially in the last 4 or 5 years, give or take. Maybe even slightly. No, 4 or 5 years, something like that. But it has created a lot of issues in a lot of creative industries in particular, where it's being made to create written or visual content, and also audio content as well. And unfortunately, when I say visual, mostly it was image content for a while, but now it's starting to move into the video content sphere as well. And unfortunately, because of the data it has acquired and the sheer amount of data that it can generate new content from, it's actually starting to drive out creators from various industries. So many freelance artists, so many novelists and journalists in particular. Heck, even YouTube content creators and musicians. Generative AI has already had a very negative effect on a lot of these creative industries. Remember some of those strikes that occurred in, what was it, 2023? Or was it last year? No, wait. It was 23 or 24. What am I already forgetting? I thought it was last year, but maybe it was before that, because I tend to misremember recent stuff. But it's already had such a negative impact on so many creative industries, and it's taken the human element away from it in so many ways. Because if you think about it, it's a data of actual human-made content. And all you do is just type in a few words, and boom, you have an image, a video, some kind of audio file, and maybe you make some tiny edits to it, maybe you don't, but in any case, it's generally lazy and it lacks so much of the actual human element that is used when originally creating these pieces. I'm an artist, I have drawn for a very long time. I'm also a novelist and a YouTube content creator. This kind of stuff could directly impact me. It has directly impacted me. It has directly impacted so many creatives out there. You know, people are losing jobs, they're losing business, they're losing gigs. I mean, this is not just for freelancers. This is for professionalists or professional creatives as well. People that have been in the industry, even some big names that have been there for years, decades, who knows, are feeling the effects of generative AI. And it just takes the human element out of it. And that really bugs somebody like me because that's what being human is. It's being creative and innovative. That's one of the big things that makes humans human. And the fact that a machine is essentially replacing so many people in what should be like, if it wants to do it in maybe some scientific industries, like if it's being used for a positive purpose, that's one thing. More often than not, it's being used for a negative or abusive purpose. And it's already causing a lot of problems, and it will continue to cause problems without regulation. And for the similar reason, like, you know, being able to, like, you know, have like virtual realities or digitally transferring consciousness or something like that, it makes me nervous because it feels like it's taking a human element out of what we are. I personally do not want to have my consciousness transfer. I don't want to have crazy hyper realistic digital reality that we just live in all the time. Like, I don't want any of that stuff. I want to be me. I want to be human. Like, I can certainly have some digital programs translate what I'm doing. Like, you know, I'm in a digital art program, Krita. Like, I'm using a digital pen on my digital tablet in order to, you know, create specific strokes, and it translates that onto the screen and stuff like that's one thing. Like, I'm just using tools, but I don't want something to outright replace me in a way that just doesn't feel human. It is kind of unsettling what technology can become without some kind of regulation or limitation. Because at the end of the day, we should be, you know, celebrating and preserving what makes humans human.
The happenstance offerings of nature would struggle to compete with the promise of utopia. Throughout the galaxy,
Utopia does
pockets
not
of
exist.
advanced
It will never
civilizations may
exist.
occupy no more than a few star systems as they explore inner space in place of outer space. In his transcension hypothesis, futurist John Smart takes it a step further and
What a
supposes
last name.
introverted evolution will progressively miniaturize computers until they are so intensely compressed that they generate an environment analogous to black holes. These post-biological
Interesting.
civilizations would thus transcend the space-time continuum and vanish from the visible universe.
Mm-hmm.
Hypothetically speaking. Apart from
Hypothetically,
artificial
yeah. Let's
transmissions
hope it
and
stays that way.
distant signs of astroengineering, there's also a far less remote form of technosignature. The Voyager spacecraft was launched in 1977, and as of
That's
the making
right,
of this
Voyager.
video, it is the only probe to have reached interstellar space. It famously carries a golden
That is kind
record
of
with
cool.
information about mankind, but it will take another 40,000 years before the probe encounters another star. In an effort to more expeditiously explore the galaxy, an advanced civilization may launch sophisticated interstellar probes capable of self-replication. These probes would be intelligent enough to mine the available resources in any given planetary system to create copies of themselves. These copies would then travel to neighboring systems and create additional copies. If these probes could travel at just 10% the speed of light, a speed attainable by modern methods of propulsion, every corner of the galaxy could be exhaustively explored in just a few million years, a relatively short amount of time on cosmological timescales. Mankind is now fast approaching the technological sophistication to launch such a probe. This begs the question, why is the solar system so probeless? If human progress is any indication, the galaxy should be completely overrun by self-replicating automata, Yet we see no evidence of that.
Nope.
An ongoing hunt for alien artifacts has yet to locate any covert probes lurking in the solar system. But space is
How
vast.
do we
An
even know they're
object
out
of
there?
extrasolar
Is the thing.
origin could easily be zipping around our cosmic backyard without our knowledge. In fact, that is exactly what
Kind of
happened
unlikely,
in
but possible.
2017. An extrasolar object named Oumuamua passed through the inner solar system and went completely unnoticed until it was moving away from the sun.
Huh.
Even then, its discovery was pure luck, and thousands of extrasolar visitors could go undetected each year. The
True.
size and shape of Oumuamua can only be inferred by the amount of light it reflects, but it appears to be highly elongated or extremely flat. Initially, it was thought to be a comet, but the absence of a cometary coma, a trailing cloud of dust and gas typically formed when comets approach the sun, lent credence to it being an asteroid. But then the object began to accelerate. This acceleration would be consistent with the outgassing of a comet, but as mentioned, Oumuamua does not display the expected characteristics of a comet. One possibility is that this outgassing is simply too faint for us to detect, but there is that remote possibility of it being an interstellar probe. More specifically, a probe using a light sail as a means of propulsion.
Hmm.
On the other hand, Oumuamua is perfectly radio silent. Perhaps it's a defunct probe destined to aimlessly roam the galaxy, much like Voyager.
Fascinating. No, this is something I didn't know about.
It's important to remember that with a sample size of one, that being Earth, we cannot possibly know how common or rare life truly is. There could be hundreds of planets or millions of galaxies between us and them.
Yep.
If life was discovered elsewhere in the solar system, perhaps beneath the frozen mantle of Europa, we'd be able to compare and contrast two distinct sources of life and gain crucial insight into its commonality or rarity. Many reject the anthropocentric view of Earth as a cosmological oddity due to the sheer number of Earth-like planets coupled with the resilience of life on Earth. But the truth is, we don't know. We don't know if billions of planets is sufficient for intelligence to arise more than once. We don't know the prerequisites for abiogenesis, the transition from non-life to life. We don't know the
Yeah,
probability
true. We can
of
only speculate,
cosmic
even based on our own
solitude.
planet.
But to conclude that we are alone in the face of all this ignorance is more than a bit presumptuous. The extent of our
A little
search for
bit.
extraterrestrial intelligence has been compared to searching a glass of water for evidence of fish in all of Earth's oceans. Space is unimaginably vast, and we have barely begun to scratch the surface. There are
We don't
so
even know if
many
there's an
untapped
end.
avenues for detecting signs of life that if we just turned that telescope a bit to the left, made it a bit larger, and listened to a slightly different range of frequencies, perhaps the universe wouldn't be so silent.
Hmm. Nice. I will let this go ahead and play. Thanks to all patrons. I'll go ahead and let the patrons go on screen too, because I know Let Me Know has had lots of patrons. Even like 6 years ago, he still had so many freaking patrons. It was really cool for him to use the sound effect as both an intro and an outro. Because if you think about it, it really just goes to show the true unknownness of everything. I'm a little sad he didn't talk too terribly much about the Fermi paradox. It was more of a brief mention, but I personally think that it's a really cool concept in regards to astronomy and science in general, especially when looking at the expanse of the universe and the potential implications of extraterrestrial life. So generally speaking, the Fermi paradox is like a sort of examination of probabilities and probabilistic values of sorts. And it's completely all hypothetical in nature, but it does kind of make you think about, the potentials of not even just extraterrestrial life, but general probabilities of how the universe exists in of itself. So I mean, say for example, you have every single planet that orbits a star of some kind. Heck, or maybe just planets in general. what's the probability that, that planet is going to be orbiting a star? What's the probability that that planet orbiting a star is in what we determine to be the habitable zone? What is the probability of those planets in the habitable zone that have developed single-celled life? What is the probability that those planets that develop single-cell life also developed multicellular organism through evolution? What is the probability that there was, some kind of, of the multicellular life, that there was some kind of extinction event that a planet was either able to avoid or push through? What is the probability that a planet that has or hasn't gone through an extinction event was able to, develop a civilization of some sort? What is the probability that a civilization that developed on a planet with life was able to develop, complex civilization and interstellar travel or something like that? Like, you saw how I just kept going down and down, because there are so many factors that are required in order for there to be a civilization even similar to ours in the slightest, for extraterrestrial life to be able to, like I said earlier, receive our signals and then transmit them. Because there could very well be so many other planets with life on them, but either it's simple life or it's complex life that doesn't have the ability to send and receive messages like what we can do with our radio transmissions and satellites. And again, it's all hypothetical, because these probability numbers that shrink over time with each new specific instance, we don't know what those values are. Or at least we do, but they're pretty much estimates at best. But I find that paradox to be interesting. There's another paradox or some kind of astronomical concept that is also very well known. I just cannot remember the name of it. If I saw the name, I'd be like, yeah, that's what it's called. I just don't remember the name of it. But I love the Fermi paradox because it absolutely makes sense. Because if you think about it, that's exactly what happened with Earth. Is that we had 4.5 billion years of, well, for a good portion of it, I want to say like almost half a billion or a billion years, our planet was just a slew of lava and falling fire rocks, essentially. And one of those, or not one of those, but some of them just happen to have the right molecules that allowed water to begin forming. So, our planet, it was formed by a collision with Theia and became Earth. Well, it just happened to be in the habitable zone. We just happened to get particles from space that came down in meteorites that created water, that eventually created the entire planet as an ocean, and which eventually created an atmosphere. Oh yeah, atmosphere. Duh. Not even just a habitable zone, but a planet capable of housing some kind of makeshift atmosphere where life can potentially develop. And then where life actually does develop. And life didn't even start developing until a couple billion years. And even then, we don't necessarily know for sure. Life could have formed as early as 3 billion years ago, or as late as maybe 1.5. Something like that. We don't actually know for sure. We do have very good estimates, but we technically don't know for sure around when the first particles of life actually came into existence. There's still such a huge time gap. But even then, it still took hundreds of millions and probably over a billion years for single-cell organisms to start developing into multicellular organisms, and for those multicellular organisms to grow and grow and grow. And even across 4.5 billion years of existence of this planet, we still had 5 major extinction events, which shifted and shaped, the state of our planet like never before seen. I mean, we're talking cataclysmic events, 4 of which were a result of the planet itself just going haywire, essentially. One of which was actually an external event. Can you take a guess as to which extinction event that was? It's the obvious one. But we're talking major climate and or terrain shifts that cause these massive extinction events. Whether it was the planet itself, or outside events. And based on the state of our planet right now, based on what we've done to it especially, I feel like we are supercharging its potential for another extinction level event, or at the very least, a human-made catastrophe. Human-made global catastrophe at that. Global. It is so much more likely that we are headed for a global catastrophe in the near future compared to a century ago. It is so freaking likely. And do I have empirical evidence to back me up? Not really. It's more of a hunch, if I'm being honest. And I know that probably doesn't sound super reassuring, but I'm a scientist at heart, man. Science is my lifeblood. I love being creative, but science is the lifeblood for my own existence, my own sanity. And based on my knowledge, my observations, and just general gut feelings, which I don't even have a lot of those, I just have a feeling that we're going to reach some kind of global catastrophe in the near future. Do I think it's going to happen in my lifetime? Most likely not. There is a possibility, because I think a small possibility, but most likely not in my lifetime. Maybe in a few generations? Yeah, possible. I do honestly think that the next major global catastrophe, extinction level event or otherwise, is going to be caused by humans. And I would not even blame the planet. We have not treated it well. We have not. But in any case, I think that extraterrestrial life does exist out there. I think it very well could. Now, whether something is just as advanced as us or more advanced, I don't necessarily know. And the thing is, especially with, radio transmissions, sometimes they can reach some places very quickly. Other times, it could take years, decades, freaking centuries, millennia. We don't exactly know. It could take a while, depending on how far away it is and how jumbled our signal still is. If it's even still coherent, it could be so diffused that it couldn't be determined where it could possibly come from or what the content was. Who knows? So, if we meet extraterrestrial life, which, again, I do think that there is somewhere out there in the universe, in the wide, wide universe, that we don't actually know if there's an end. Heck, it could wrap around itself in a weird way. I don't freaking know. The universe is so freaking unknown. It's massive. It's vast. It's unknown. There are so many things we still don't know about it. And I don't know if that's by design, but I don't think there's anything we can do about it. I don't think we will ever know the true extent of the universe. We still don't understand the extent of our own planet in so many aspects. How the hell are we going to understand the whole extent of the universe? Just saying. I really extended the commentary on this one. Granted, I did have to step away a couple times, but I really extended the commentary on this one. Not that I'm entirely sad about it. I mean, does my voice hurt just a smidge? Maybe just a little bit, but I certainly enjoyed it, because I do find stuff like this fascinating. Not a conspiracy nut job. I'm not about to make any kind of presumptions of any kind. I'm just talking about the scientific empirical standpoint of the most likely and least likely scenarios, or even just middle likely scenarios, who knows. Thank you to the viewers, I can't remember how many, who suggested that I watch this. This was actually very cool. Now, Let Me Know has a bunch of patrons, and guess what? So do I. I do have a bunch of patrons. Not nearly as many. I wish I had as many patrons as Let Me Know, but unfortunately I do not. So I'm going to go ahead and just kind of show their names right here. Thank you all so much, not just to my patrons, but even my community as a whole, for sticking by me for all of this stuff. Allowing me to process as much commentary as possible, because I'm pretty sure the final video is going to be like certainly 4 times as long as the original Let Me Know video, which I consider a success, because that means that I provide my own thoughts, my own commentary about the subject. I like doing that. So, that's that. Thank you all for watching. I hope you guys enjoyed this. And as usual, until the next video, guys, check you laters.